Hey people, welcome to our today's tutorial. We are going to look at this question that came in 2023 question 3b exam pharmaceutical chemistry and analysis third year pharmacy at Ridgeway. This question is under benzene chemistry, which is on the electrophilic aromatic reaction, which is nitration. Let's try to answer this question. It is 6 marks. So we can't afford to lose these marks. Write a reasonable mechanism for the reaction shown below. When you look at this reaction, this is a benzene reacting with these reagents at 0 degrees Celsius, forming this. This is nitration. So we need to understand about this. This is nitration reaction. Don't forget about that. And then, we don't write the steps like we learned here. It's just a continuation. But what you need to know in mind is that the first step is generation of an electrophile. How? I'm going to get this nitric acid. This is a nitric acid and this is a sulfuric acid. Don't forget about that. And it is taking place at a condition which is 0 degrees Celsius. So here it's like this. Don't forget. Then with a positive here. Then, as we know that we have also this sulfuric acid, which is acting as a catalyst here. This is sulfuric acid. So what we need to know is that the first step is generation of an electrophile. We want to generate an electrophile which is added on the benzene ring there. But looking at this, there is no hydrogen, so we have only two oxygen and nitrogen. We want to eliminate hydrogen and oxygen from here. So how can we do that? This OH, which is here, it is a poor leaving group, so we're going to make it a good leaving group by getting one hydrogen there, and these electrons will come direct or toward the oxygen. So here I'm going to write something like this. What am I going to form? I'm going to form this, which is O, or let me just put it in this way, this H here with a positive, or I can put it on top the way I've written it. So this is the oxygen here. Here I'll put it on top like that. Here is a positive like this. Then here nitrogen. Like this, you get? Plus this, which is a base which will be formed. Why? Because it has lost a proton. Here it has lost a proton, one proton. It has become now with one hydrogen. Then you act as a base, that one. Then when we reach there, we are going to have this structure, which is like this, with the hydrogen there, with a positive like this, with a positive like this. So since now it has become a good leaving group, this one will go and these electrons will come back here. So we are going to form something like this with a positive plus the water that has left, like that. This is the water that has left. This water molecule is going to be lost. Why? Because now a good leaving group, and these electrons will come back to make a double bond like I've shown, like that, plus water which has been lost there. Then this which have formed here, let me even use a red color, this which have formed here, that is an electrophile which we are going to use there. Don't forget, this is an electrophile. Then remember we said step number 2. Okay, we said okay, remember we said step 2 is to a pi electron or pi bond of a benzene ring will attach itself to an electrophile to form non-aromatic carbonation. So here this is an electrophile which we're having. Okay, so the benzene is not like this, it's like this. Let me just write it exactly where it is. So here, let me write it. Okay, it's like this, like this, like this. Okay, then see the way it is. So I'm just going to say this one pi electron will come and attach itself to an electrophile. Then here, immediately when it attach, this bond will open like that. So the way I'm going to write it, I'm going to write it like this. I'm going to write it like this, which is here to be like this, then here. So here it can be written like this, which is here with the electron there because it has opened. But if you don't want, we need to write like the way it has been written, which is NO2 like that. Okay, then here it will have a positive like this. So now when I reach at that point, I'm going to say this is aromatic. This is not aromatic, it's non-aromatic carbonation, which is also known as rhenium ion. It's also known as rhenium ion. So I can form the resonance form. So here it's better you form the resonance form. I can write like this. I'll write them down there. So how can I form the resonance form? You say for this positive here, since this pi electron is going to attack here and it has gone to attach itself to the electrophile and it has made a bond there. Then since here it has broken, we are going to have it's not stable because you know carbon it has four valences which forms 4 bonds, but here it has now 3 bonds. One bond has gone, that's why it has a positive. Then for us to stabilize this charge here, we're going to say this bond will break and come to this. So here I can write now to say, this bond will come there, then here there's an electrophile, something like that. Yeah, then here it's like this, then the charge will be here. You get? The charge will be there now because now it has broken to form a bond there, and the charge will be there because now it has become stable as well. Then for us to make this charge again to be stable, this one can break and make a double bond there. Then what will happen is that we are going to have something like this. Then here there will be a bond since this one has broken and form a bond there. Then here there will be a positive. Then the charge is now next to the electrophile. We can say this has got 3 resonance or 3 rhenium. So these are called rhenium resonance like that. You get? So when you reach at that point, you say, let me now restore the benzene which I'm having, or which I had at first. Let me restore it. 1 proton from the carbon that base, or a proton that is from the carbon that bears an electrophile is going to be lost, and that bond is going to form a pi or a bond to restore the benzene ring. So how am I going to do it? I'm going to do it like this. So looking at this, you've seen like the way it looks, that's the way it is like that. The benzene which is here is the way it is. So I'm going to get, see these resonance are just the same, but I'm going to get the first one because that's exactly the way it will form what we want there. So here there will be positive here, then here there will be nitrogen, this which is NO2. So here there is a proton which is on the carbon that bears an electrophile. It's the one that's supposed to be lost to make a bond there to restore our benzene ring. So what are we going to do? We are going to say At first, when we were generating an electrophile, we form a base. A base is the one that we are going to get there. We can get the base, which is this with the negative there. So we'll come and grab this hydrogen. Then this bond, or this bond, will come and make a double bond there, which is which will be involved in the aromatic ring. So when we reach there, we're going to have this. Okay, we're going to have this NO2 like that. Then here there will be a double bond, or here there will be a bond, even here there will be a bond, and it has been restored the way it was. So here we can say plus. When you add proton to this, which is the base, you are going to have H2 H2 sulfate, which is the sulfuric acid. We have started with an acid and we end with an acid. So we are done with this, which was 6 marks. The first step is generation of an electrophile, but we don't write like step 1, step 2 like the way we were learning. Here now we are answering exam standards. We just start. Like this one, generation of an electrophile, this nitric one, since OH is supposed to leave for us to have NO2, then we say we want to make this one to be the good living group. Since OH is a poor living group, we'll get one hydrogen from this sulfuric acid, and it will be water like the way it has formed here, plus this one, since this one has lost a proton like that, it has a negative. Then here when we reach here, we say this, now this is a good living group, will go and these electrons will come back forming this, plus water which has left. Then when we reach there, a pi bond of a benzene ring will attach itself to this, which is an electrophile, to form a rhenium ion. Then we can also write there a resonance form, which are called a rhenium resonance. This one positive will be here, the bond has broken and formed, and it attaches here like the way I've written it. Then here it will be unstable with 3 bonds, that's why it has positive charge. Then we're going to say this can be stabilized by breaking this bond, forming a bond there, and it will be a charge here where it has left to form a bond there. Then also this one, for it to be stabilized, this charge for it to be stabilized, we can say this bond will be broken and form a bond there, and where it has left to form a charge. And when it is next to the electrophile, then we have the number of resonance form that you have, which is a rhenium 3 resonance form, and it is stable, which will make the transition state to be stabilized. That's the reason why we use this resonance stabilization effect. And in that case, we are going to make the forward reaction to be favored. Then the step 3, we said since this one is non-aromatic carbonation, it's not aromatic ring, it's supposed to be restored to be a benzene. So restoration of a benzene ring, we are going to say a proton on the carbon that bears an electrophile is going to be lost, and that bond is going to form a pi or a double bond there inside to restore the benzene ring. That's what we have done here. The base that we created, or the base that we formed at first when we were generating an electrophile, is the one that is going to attack or grab this hydrogen, and this bond will come and make a double bond there, and finally we are going to have this as our structure. So this is our structure that we have, and when you check there, you have this. Remember, the reagents are very important. 0 degrees Celsius and this, which is nitric acid, and also sulfuric acid, because sometimes you may be asked on these reagents. We need to know, just looking at the reagents, you can tell that this is nitration. We are not told in the reaction say this is nitration, but you can tell by looking at the reagents. So this was the question, and it is 6 marks. So you can start counting that I've gotten at least 6 marks there, 20 marks, 8 marks there, by just knowing this simple concept. Thank you so much, guys, for watching this video. Please subscribe for more videos.